Hey, how are you? I'd like to make a quick video to help you out with homework number 9, which is all about piecewise functions. I have an example here. It says, give the following piecewise function, evaluate f of 0. Okay, so notice what we have here is we have a function in 3 pieces, so that's why it's called a piecewise function. We have the first piece, negative 4x plus 1. Now out to the right is directions. The directions x less than negative 4 means you are only allowed to plug in x values that are less than negative 4 into this piece. Whereas the middle piece, negative 3x, says that you choose x's that are less than or bigger than or equal to negative 4 or less than 0. In other words, x must fit between negative 4 and 0. You can include negative 4, but you cannot include 0. Okay? And then the last one says you use this piece, x squared minus 2, only when x's are bigger than or equal to 0, or 0 is less than or equal to x. Now, this problem is not asking us to graph at all. It's just asking us to substitute 0 into the function. Now, what you don't do is plug it into all 3 pieces. You're only going to be allowed to plug in a number, an x value, into one piece, and that's using these directions over here. So the question is, where does 0 fit over here? Is 0 less than negative 4? No. Is negative 4 less than or equal to 0 less than 0? No. Is 0 less than or equal to 0? Yes. That means this is the equation you use. You plug 0 into the bottom piece of the function. So you would have 0 squared minus 2. We know that 0 squared is 0 minus 2 is negative 2. So your answer is negative 2. Now if I scroll down, and I want to type in my answer right here. Uh-oh, I don't want all that. I'm just using a stylus, so I type in negative 2. I had to go get my keyboard to actually do that easily. And push submit, and we'll see if we have it right, and we do. So again, the information on the right is telling you what x values you're allowed to plug in. So I could only use the top equation if my x was less than negative 4. I could only use the second equation if my x was between negative 4 and 0, including negative 4 not 0. And then we only use the last equation for x is bigger than or equal to 0. That's why we use the last one only. So let's find another problem that might help you out. All right, now here's a good problem. Which of the following piecewise functions is represented in the graph below? So I've noticed there's 3 types of problems. There's the problem we just did where they give you an x value and you just have to figure out which one to plug it into and plug it in. Or they give you a piecewise function and you have to graph it. My advice is to use your knowledge about graphing straight lines and those toolkit functions to graph it on your own and then match. And then this one, and this may be the most difficult type of problem that shows up in homework number 9, where they give you a graph and you have to identify which of the multiple choice answers is correct. And so we want to break this down into as much detail as possible to help you out. Now here's what I noticed. Look, there is a straight line right there. How do you write the equation of a straight line? Y equals mx plus b. Our third piece over here, another straight line. How do you write the equation of that line? Y equals mx plus b. And then in the middle here, notice we have a parabola. This is going to be an x squared function. This is a quadratic equation. Now, the first thing I want you to focus on is where these pieces are defined. So look at this piece right here to the left. Notice it ends right here at negative 2, and negative 2 is not included. So I want to write my interval down first. So if we have a function that's defined so that you're talking about numbers less than negative 2, but negative 2 is not included, you would just write x is less than negative 2. Okay? Now we could go back and look at the function and write the next interval, right? We'll go back and define this equation, but let's just write the next interval. So notice the piece in the middle right here. Okay, so we talked about x less than -2 is over here. In the middle, it goes from -2. Notice that's a filled in dot, so it's included, all the way to 1. I'm just looking at x values, no y values. So I'm talking about -2 is less than or equal to x is less than 1, right? Because this graph is graphed between -2 and 1. The -2 is included because it's filled in. The 1 is not included because it's not. Again, only x values. So let's go write that down. Okay, so we said -2 is less than or equal to x is less than 1. Again, why the -2 is less than or equal to? Because the -2 had a filled in circle, but the 1 didn't. So let's go look at our last piece. Now, the x values for this last piece, which is a straight line, look how it starts at x equals 1. We don't care about the y. The y is -2. We don't care about that. It's x equals 1. Look, it's included. So we have a less than or equal to situation or a greater than or equal to situation. And it goes to the right forever. As a matter of fact, this graph would probably have an arrow at the end over here and an arrow at the end over there. So we're going from 1 to infinity for our last piece, or you could say x is greater than or equal to 1. So I got x is greater than or equal to 1. Now I want to see if I can't write the equations for our lines. Now, if you'll remember, this first one was a straight line, so we're talking y equals mx plus b stuff. And remember, the third piece was a straight line also. But the second piece was a parabola. So let's go back to that leftmost piece and try to write this in terms of y equals mx plus b. Now what's important about y equals mx plus b? Well, the b value, right? It's the y-intercept. Now look, this line doesn't have a y-intercept, but you know what? It really does. If I could extend this line, notice if I could extend that straight line, it would cross at 1. So 1 would be my y-intercept. I also need the slope. How do you find the slope? That's your m value, right? So you go from one point that you can clearly see, say for example this point, and then there's another one. Notice I go down 1, right 1, and I land right on the line. I go down 1, right 1. You know what that means? The down is the numerator of the slope, -1. The right is the denominator of the slope, which is 1. So my slope is -1, and remember my y-intercept, if I extended this line, would be 1. So how do I write the equation for that? Let's go back and look. So if I use this format, we're not going to do the y equals part. That's just a given. But my m, remember, was -1x, and my y-intercept was 1. Okay, now a better way to write that would be just -x plus 1, right? Because we don't really write -1 for our slope. We just say -x when we multiply -1 times x. So instead of writing, I'm trying to erase, it didn't work out. Instead of writing -1x, I'm going to write -x plus 1. And I don't write y equals, you know why? Because way over here we have f of x equals, and that takes care of that. So this we handled. I'm going to get rid of my y equals mx plus b up there because we don't need it anymore. Now let's look at our third piece. Since we're busy talking about straight lines, let's go back and look at our third piece, which is also a straight line. Okay, so our third piece, remember, was defined from 1 to infinity, or x greater than or equal to 1. Now, we need the y-intercept, not the x-intercept. We don't care about that. We need the y-intercept, which would be down here. If I extended that line, it'd be -3, right? So my b value in y equals mx plus b is -3. What's my slope? Well, let's find a point we can clearly see on the line, maybe this end point, and then another grid where it crosses the grid line is right here. So I go up 1, right 1. To get to another point, up 1, right 1, up 1, right 1. What does that mean my slope is? +1 on top to represent the up, and then +1 in the denominator to represent the right. So my slope for this line is +1 because this is increasing from left to right. And remember, my y-intercept is -3. So when I write that, so remember we had 1 for my x value, my m value, and then you always leave the x in it, and then -3 was your b value. Okay, so that is y equals mx minus 3. Now the 1 for the slope, once again, we're not going to write that because 1 times x is just x. So there's our third piece. And I'm going to get rid of the 1 also because we decided we don't have to write that. Now the middle piece we said was a parabola. Let's go back and take a look at that one. And here it is. Notice that's in the middle. Now what's weird about this parabola? Well, it's upside down for one thing, right? But it's a regular parabola because if we flipped it up, we would be crossing at negative 1, 1 and 1, 1. Well, this is the same thing but upside down. And then the next point, if we plug in negative 2, we get negative 4. So this is negative x squared. Okay, so if you had to write an equation for that parabola or a quadratic function, it's because it's upside down, it's negative x squared. All right, so I go back and I write that down. And I have negative x squared. Now when I check out my multiple choice, I need negative x plus 1 when x is less than negative 2. I need negative x squared when x is between negative 2 and 1. And I need x minus 3 when x is greater than or equal to 1. So matching wise, that's what I'm looking for. Okay, so let's see if we can't find that match. And I flip back over and I scroll down. Okay, now remember negative x plus 1 for x less than negative 2. That is what we had. Negative x squared when negative 2 is less than or equal to x is less than 1. Hey, that's what we had too. And then x minus 3 if x is bigger than or equal to 1. Look, y'all, this is the very first choice. Now, I always like to look at my other choices that are wrong just to be certain I'm not making a silly mistake. Also, it says select the correct answer, not all that apply, something weird like that. Always look out for that too. Now, we know the left piece when x is less than 2 is not x plus 1. You know why? Because that means the slope is positive 1, and that would be rising. And we have a negative slope here. So we know that answer 2 is out. Answer 3 is out for the same reason. Look, another x plus 1. We don't have an x plus 1 because x plus 1 would look like it was rising from left to right, not falling from left to right. Okay, so that takes care of answer 2 and 3. In answer 4, you have negative x when x is less than 2. Now, it is a negative x, but there's no y-intercept, which means the y-intercept would be 0. And y'all, if you extended that line, that y-intercept is not going to be 0. It's going to be up here at 1. So really, these answer choices all focused on this one piece right here. But I think it's good to try to figure it out on your own. But there's always ways to speed this up by just kind of trying to eliminate the options by looking at your choices first. So we're going to go ahead and submit. Let's just see if we got this thing right. And notice we did. So I think that's the best way to solve these types of problems. Now, what I didn't do is an example that we had to, where they gave us the function and you had to match the graph, but you can do that. You can plug in points, you can pay attention, and I do a lot of that kind of stuff in the videos. Okay, I really hope this helps out a lot. Have a great day.